Aloha, it's Steve, and today I'll show you how to implement a 3D physics-based dice roll system in your game. This video is an overview of the main concepts. The code and the project template are available with the link in the description. It's free and under the MIT license. Let's start with ticks per second, or TPS. TPS refers to the number of physics calculations done per second. It heavily affects how the simulation feels, including issues like tunneling. Tunneling is a behavior in which an object passes through other objects, ignoring collisions, as we see on the screen. Default TPS in Godot is 60 ticks. This project uses 120 ticks for a smoother simulation, which still remains manageable for most mobile devices. Aside from TPS, three other settings significantly influence the simulation: linear, angular damping, and gravity. When adjusting TPS, you should also tweak linear and angular damping, since their behavior depends on it. As for gravity, I stick to the 80% of real world value, because turnouts, dice rolls in the real world may look pretty boring. In addition to project settings, damping and gravity can be modified in the rigid body 3D properties, or using an area 3D. Also, to keep the simulation stable and prevent extreme cases of tunneling, I recommend limiting the maximum velocity of the dice. Another important detail is that for optimal physics simulation, dynamic objects should be between 10 cm to 10 meters in size. The size of real dice is about 3 cm, so we need to scale it up. Godot doesn't support scaling of collision shapes, and you need to change the collision shape's extents separately. Since we import collision shapes from 3D model, we will change import settings and set the root scale to 10x. You can apply this per asset or globally in project settings import defaults, for consistency across all assets. Take a note that changing import defaults won't affect already imported assets. One more thing I want to mention is physics material used for the floor, walls and dice rigid body. Feel free to experiment with the values, but here is what looks nice to me. Once the simulation feels right, the next question is how we determine the roll result. To detect which side is up, we place a node 3D at the center of each side, which will represent its position and number. Then, to get the result, we just check which side is highest along the y-axis. While you can eyeball this in Godot editor, it's much easier to do in 3D editor like Blender. I'll show you how to do that with Blender and custom import script later in the next section. Now let's walk through to the full process of adding new assets to our template. I will use the RPG dice set asset pack. It includes dice from D4 to D20, with 24 color variations. You can find a link in the description. First, move the assets into the project assets directory. Main mesh setup is straightforward, and we can import the mesh as is. Since our asset pack comes with a lot of material variations, I will save material as an external file, so I can change textures later. Then we will import collision shapes. By default, Godot imports collision shapes as children of static body 3D. So we will use a custom import script to import only collision shape, which we will later add to our dice's rigid body. Here is our collision shape. Apply import script to remaining files. To apply import script to multiple files, apply the script to one file, copy the path value, shift select other files, pass the value and click re-import button. Now to the dice side setup. Our dice set already comes with a side file ready to import, but I will show you how it can be done in Blender for other models in a moment. The same way as with collisions, we apply import script to all sides files. And this is what we should get as a result. To create side files for other models, in Blender optionally create a new collection. In Edit mode, select face or faces of dice side. Switch to Origin tool and set orientation to geometry. Click on the selected faces and snap cursor to selected. Switch back to object mode. Add an empty and use align to transform orientation. Set orientation to cursor. Rename our empty following the pattern. Repeat for each side. To save some time, I will duplicate the empty and rename it. You may also add align to transform orientation action to quick forwards or assign it to a shortcut. Select all sides and export them as LGLTF file. Now it's time to assemble our imported parts into dice rigid body. Start with duplicating existing dice scene. Add imported dice mesh to the scene. We will double check that our scale is correct and remove all nodes. Next, add Sites Manager to this scene and enable Access as a Unique Name option for this node. Move collision shape to this scene. Adjust the mass if necessary. Note that the mass must be scaled button X, just like the mesh and collision shape before. Save this scene. Now we need to create a resource that tells the game manager how to display our dice in the UI. I will duplicate the existing one and set scene and label to new values. Be sure to hit Ctrl+S to save the changes, otherwise Godot will discard them. Then add the new dice resource to the game settings resource. And don't forget to save the changes. Let's look at the result. My free template have knobs you can play with, so make sure to check the link in the description. There is one more trick to implement. Let's say we set up the field and dice, push a troll button and it's not quite what we expected. We return to the editor and add an invisible ceiling to our field. Okay, the trick is to disable collision of dice rigid body on throw, and only enable it when the dice is inside the field. To enable collisions, we use Area 3D with custom code. In this way, we can minimize the probability of the dice going out of bounds. In most real game scenarios, you will also need to check that the dice do not go outside the playing field to avoid soft locks. And that's all for today. Make sure to check the video description. Tickle the like button if you found this video useful. Subscribe and leave a comment with your questions or ideas for future topics. And aloha!